Welcome here at our first Android talk in this year. And firstly, I would like to establish just few basic rules so it can all run smoothly and you can enjoy this event as lifelike as possible. So you have many options how you can interact with the speaker or another attendees. You can firstly you can raise your hand. We will unmute you and you can ask the speaker directly. So this is like the straightest way. Also, you can write down your question into an Q&A section, or you can write in the chat section. So that's basically all from me. If you have any questions and you are watching us on YouTube channel, please write down the questions over there as well, and we will make sure that the speaker will answer them. Okay, so now I would just like to introduce our speaker, Juraj Kuliska, Android engineer at STRV, and along with him, Václav Tarantík, Android platform lead at STRV, who I would like to give a word right now. So thank you very much and enjoy.
Thanks, Katka. Hello, everybody. We're really excited to have you here. I have just one thing I want to mention. We're currently hiring a new member of the Android team. So in case you're interested or you know about someone, please let us know and spread the word. We'll be super grateful for that. And now I'll pass the word to Juraj and let's enjoy this wonderful event together.
Thank you, Katka and Vasek. Welcome everybody. I hear that we have both attendees on Zoom and YouTube, so welcome. And you know the YouTube drill. It's just like comment, like, and subscribe. So don't forget that, especially the commenting. And yeah, I'll just share my screen real quick, and we can start the presentation. So as you probably know, we'll be talking about testing Android apps today, especially with coroutines. But as you will see, the principles might apply for other technologies as well. Firstly, I know this is kind of a topic that different people have different opinions on. So maybe some people test, maybe some don't. So I would wonder how if I can change your opinion on testing if you are not really a big fan of it. And yeah, so that would be one of the goals of this talk. To start, there are different approaches to testing, let's say. And as you can see, we'll probably go through quite a lot of memes in the presentation, but then we'll actually get to the real stuff. So one of the approaches that not everybody, but maybe Chuck Norris can afford is testing in production by the real users. So it's one of the approaches that some maybe YOLO developers try to employ. Other way of getting around testing is the tests can't fail if you don't run any or if you don't write any. So that's one of the rather, in quotes, smart way of approaching testing. The argument I hear most why not to test is basically this, that either your client or your company doesn't quite support that time-wise, and so there's a lot of pressure to develop, and the tests are always put on a sidewalk, let's say. But there are also people who are who think that in the future it will hunt you down, and not having tests will result in you not really having a good time at some moments. So then what happens that if you're not testing, then one day a huge bug appears in production, and you wake up that morning and you start thinking, well, I should start testing. But if you already have this motivation, even you burned yourself, But then the next questions that you might ask yourself would be, what do you test in Android apps? How do you test? Where do you start? And are there any fun benefits? Which there definitely are. This is actually the questions that were holding me back from starting with proper testing of my apps in the past. But then once you actually know some principles and you know where to look, what to test, then you actually kind of start enjoying it, and you create a routine how to develop your code, and then you even feel like it's strange to write something without tests. So let me start with the fun benefits first. I don't know how many of you would appreciate this fun benefit, but I do. So that's that's one of the things. If nothing else, even ex-president approves it, so that should be good. Then actually a real benefit, even though this might sound a bit empty, but tests actually teach you to structure your code in a way that's well testable and has an architecture that allows you for better refactoring, for example, or better splitting of responsibilities of different parts of code. So even if you are not employing the test-driven development, so you would write tests first and then the implementation, but still, if you know that you are going to write tests for the implementation that you are just writing, you will think twice how to structure it. So that's actually one of the benefits I found for myself as well. Pardon me. Then it's not an easy road. Sometimes you encounter situations like these that you actually write tests that confirm the buggy behavior, but then you fix them, and at the end of the day, it's a really great experience to watch the tests run, pass, and you just see the whole green tens and even hundreds of tests, hopefully. So, couple disclaimers. First one, won't be super easy, but it's definitely worth it. Second one, if we are talking about testing, maybe sometimes I slip a word of unit testing, but actually I think it's not quite pure unit testing what I'll be showing you right now, because unit tests should be even dumber than these tests, but we'll be testing some of the main functionalities of the app, like more complex flows, let's say. Okay, so every presentation should have some bullet points. So I have one slide with actually bullet points of how tests should be written. So they should be fast. So it shouldn't take too long. Ideally, just milliseconds or seconds to run. I remember on my current project, we had a memory leak in one of the tests, and at some point it reached, I think it ran for 20 minutes and then it failed. So not a good practice. Then they should be isolated and independent, which means that even if I run the test, just one test case by itself, it should always give you the same result, and tests shouldn't depend on each other. So it shouldn't be like, if I run the first test A, then that would be a precondition for test B. That shouldn't be the case. They should run the same way, deterministic way, in whatever order. Next up, they should be repeatable. So if you don't change anything in your code base and you run the test again, it should give you the same result. That's actually one other funny example I have from my current project, where someone wrote a test that was testing if something happens after February, and they wrote the test in April 2020. and then New Year came, and because they were just using an instance of date without actually setting the actual date, the test started to fail from January 1st. So we needed to fix that. So that's one of the things that you really need to define your mock data in the test in a way that are repeatable no matter what the conditions. Then they should be self-validating, which means that you should have the asserts there that cover all of the test cases, and also ideally they should run, for example, on a CI or by some automatic manner, so that you don't have to run them all the time manually, especially because people forget to run them, right? And last but not least, they should be thorough. So basically covering as many cases as possible, but I think a good start is to at least to start with covering the happy path, covering maybe the basic error response of API, let's say. So yeah, and then you can be building on top of it. So next up, test coverage is good, which is something I don't think is true. I think if you want to have a 100% test coverage, that's really time consuming, and it doesn't have to be bringing that many benefits. Especially test coverage, in my opinion, doesn't mean good testing. You can have each part of the code visited by the test, but it still doesn't mean the test was written in a way that actually tests everything properly. So I think it's important to find some balance there and test happy path, test error cases, test edge cases, I don't know, maximum number, minimum number, passing on a null, and so on. But you don't have to have everything perfectly covered by the tests. The code. I'll just start with some tech that I'm using in the code. So as you might have probably guessed, it's built on coroutines and flow. So hopefully you have at least some experience with that, so you won't be that lost in the talk. Next up, I'm using Coin for dependency injection. It's basically like Dagger, not that much different, but yeah, Kotlin supported. Then I'm using Hector, which is a multi-platform networking library. It's an alternative to Retrofit, for example, or other ones. It's just this one can run, for example, also on your backend. Next up, for caching the data or the persistence, I'm using Room database from Android X. Then a standard viewModel from Google. Then as some testing tools, I'm using coroutine test library, which gives you some other options on top of normal coroutines that you can and actually should use only in tests, not in the production code. Next up, I'm using a mock library, which is a library for mocking data, or like actually mocking functionalities of, for example, interfaces and so on. I'll show everything in the code. Next up, I'm using Robolectric, which is for tests that need some, like ideally you should write classes, for example, in the API layer or the repository view model that are not dependent on Android API, but there are some cases that you need that. For example, for testing the Room database, you need a context. So for that, you need Robolectric to run the tests because it also has the knowledge of Android. But ideally, it's good to avoid it because the tests run much slower. Next, Truth library. It's a library from Google for assertions. So basically, if you know the assert true or assert equals or so on, then this is just built on top of it so that the assertions are more readable. It goes like assert that something, for example, is equal to something, or is true, or is instance of. I'll show it in the code. I just like it more this way. And then actually all of the code that I'll be showing today is on my public GitHub. So, and I think after your attendance, Katka will be sending out an follow-up in an email where you will find the link to this repository. Cool. So to talk about the architecture a bit of the app, it's fairly standard, I would say. We have an API layer, a persistence layer, and a repository. So the repository asks the API for some data. When the API gets a response, either success or error, it returns to the repository. The repository then saves the data to the persistence. So in our case, to the room database, and we can observe the room database back for the changes in the data. Then we have a viewModel that actually instructs the repository to make some actions and observes back on the data that the repository is providing. So these are all the layers that we'll be testing one by one. And of course, we also have a view that is passing on some user input events and observing the data, but actually testing of the view, that will be a different topic. So for this talk, we'll be testing the API, persistence, repository, and viewModel. Cool. So let's get into some code. And so this is probably the last slide I'll show, and we'll just go into Android Studio. And actually, I would like to start by showing you how the app looks, because I feel like that would be the easiest way to get a first impression on what we'll be working with. It's a fairly simple app. I got into astrophotography recently, so I'm creating an app with an open using an open NASA API for space objects. So if we open it, it will be loading, and then after it will load some cool space pictures, actually 10 of them, some galaxy clusters, canyons on Mars, and so on, some nebulas, and so on. There's not much to do in the app, but there's actually quite a lot of to test. We can actually, one more functionality is to refresh the data, and we get a new set of pictures. So I don't know if there are any questions about till this point. Just have a sip of water and give you some time for questions.
Okay, here's the question from Omer. For old projects, what path can we follow to write tests? What is required for a project to start testing?
For old projects?
Mm-hmm.
Well, I would recommend starting from the most abstract layer. So testing things that are that basically the whole app is depending on. It will be up to the choice. Okay, we can start testing the API layer, for example, parsing of the data. That's actually pretty easy to start testing one by one. You can be slowly adding the tests. Then I would move up to, for example, the repository where the data is being mapped from one entities to other entities. Maybe some logic is happening there. Maybe we have some more complicated data structures being saved in the database. So I want to make sure that that the tests are the data is transformed correctly and put together into the objects ready for the view model correctly. I think I might actually come back to answering these questions, this question at the end of the talk, after we go through all of the like options of testing or layers that we will test, and maybe even along the path, I can say like, hey, this would be a good way to implement into the app to make it more testable. I don't know if we have a way to find out if that was a sufficient answer to that. Do we have any other?
Not yet, so let's give it a 5 seconds and we can continue.
Cool.
Let's continue.
Okay, let's continue then. Then I'll just collapse everything here, and I'll show you the structure of the app. Unfortunately, I can't be in the presentation mode for showing this, but after we enter the code, I'll be in the presentation mode so that the letters are a bit larger. Okay, so we have a simple app. As we saw, we have 5 modules: module for API, for the app itself, for persistence, the repository, and the UI. Start with the app. So there, it's super simple. There's just the app class that is starting coin. So basically, just yeah, like taking care of injecting all of the modules. That's all we need to do in the application class. Then I think it will be nice to go through the UI, which will where we will have the main activity, and there will be a fragment. We have a recycle view adapter, and we have a view model and a view state. I'll try to show everything in detail. I think the presentation. So yeah, the activity is fairly simple. It just like shows the fragment in its container. Actually, you will be seeing the APOT prefix everywhere. It's a abbreviation for astrology picture of the day. So that's how I named all of the classes. So then, yeah, if we go to the fragment, here we have a recycle view adapter, we have a binding view model that we inject, and we just fill the adapter, or like create the adapter, create a click listener on the refresh button, and the most important part here is that we are collecting the data from the view model, or like we are collecting the view state, which is defined by a sealed class. It could be loading, empty, error, or success, and the sealed class, just to show it how it looks. You have a view state, and each of the states provide you with some data, for example, some cache data that you receive during the loading, or you can receive some cache data during the error, also get the error message there. If it's empty, then there's nothing to say, nothing to show. And in case of success, you just get the latest data. Good, so if we go back, I'll just exit the presentation mode to see the structure once again. Next up, if we move up, we go to the repository. So the repository, here we'll see what the repository is exposing. This is quite important for testing, or for easier testing, I would say. have everything shadowed or like under an interface of what the functionality of the implementation actually provides, and you just want to test the input and output of those methods. So in this case, the repository, I can instruct it to fetch the latest data, and I can be listening onto the changes in the data. I don't care what the source is. I'm once again listening to a sealed class that actually defines the fetch state. So during the refreshing, I know if the API request is still running or not. And then if we go to the actual implementation, that also you can change it anytime without changing the interface. The implementation itself is internal, so it's not visible outside of the module repository. So the other modules can only interact with the interface with this one. And then we have a simple function for fetching the data. When we start fetching, it's a suspend function. When we start fetching, we set loading to true or to null. And then based on the result, we get an error or a success. We finish the loading, and here we are combining all of those inputs of loading, error, and the actual data, and deciding what's the current state of fetching of the data. Here into the repository, we're basically combining two sources of data from the API and from the persistence, but everything, the persistence is the only source of truth. So you're never directly passing on the data from the API without saving it to the database. Next up, we jump out once again. We'll have let's go to the persistence layer. Here we'll have a standard DAO. Actually went a bit crazy with the interfaces, maybe because I'm creating an interface for an interface. But this is what I want the DAO to expose, and the actual implementation. If you're using Room, then you know that it's all just abstract methods. And I don't want to expose, for example, delete methods, so I'm exposing only the get all and update data method, which just deletes all of the cache data and just inserts the new ones. Super dumb approach, but for the purpose of this talk. Then if we go to let's say if we go to persistence. Persistence is basically exposing the data to the data from the database to the repository. So this interface is public once again. The implementation of it is internal, so that we are not exposing the implementation, and it's responsible for, pardon me, for mapping the data from the database entities to other model entities, because I don't want to expose the database entity. And last but not least, we have API down here. Okay, so the API has just one function, and that's fetching and getting a response. The response is once again a sealed class of either success or error. And if we look at the implementation of the API layer, then yeah, we just call this endpoint with a key, and expect these many results. If it's a success, then then this method returns a success. If it's an error, then an error. I catch whatever exception just in case, so that doesn't crash, but actually bubbles through the error case. Cool. So that's kind of an introduction of the code base of the particular layers. And next up, we'll go to the actual testing classes. But first up, I'd like to ask if you guys have any questions to that. Otherwise, I'll just slowly move here, but you can still write or ask directly, raise your hand or whatever. Okay, so if nothing, then I'll continue, but don't be afraid to raise your hand anytime there's something unclear. I'll be building on top of each other, so just make sure you don't get lost by not asking. Cool. So how do I test the API layer? So first up, I need to realize what I'm testing. I'm testing that some remote source is giving me some data in the format of a JSON, which I created here. I have a mock JSON here, and I'm parsing the data, and I want the parsed data to be in a format that I expect, and all of the parameters of the data classes that I parse the JSON onto, they will have the correct values that I expect. So what do I need? For API tests, as that is normally run against an API, but as we talked about earlier, the test should be fast and especially deterministic, and that might not happen if you are using an actual API with the tests. First of all, they might run quite slow. Can take seconds to actually get an API response. Second of all, you can have error responses. You can have API being down or something. So you want to avoid this. That's why you are creating a mock web server. And so basically it's like an internal server that's running just for this test. It responds immediately, and you can mock what the response will be, what the response code will be, what the body of the or the payload will be. So we have a mock web server, then we need to create an HTTP client. I'll just using the base URL. Normally I'm using, in the code, I'm using the actual NASA base URL, but here I'm using the base URL of the mock web server and its port. And then I'm serializing the data with a Kotlin X serializer and ignoring unknown keys. Okay, so we have a web server, we have HTTP client, we have our mock response for success. I also created a mock response for error. It's super easy, it's not even a JSON, it just returns you that you have a wrong API, for example, as one of the possible errors you can encounter. Okay, so let's write our first test. So what are we testing? We are testing a response success. So we write it like this. In test, there's a good convenience that you can put it into these single quotes, and you can actually put spaces in between, so that it's more easier to read what the test should do. And so what do? We set a dispatcher of the web server to be for any request, and you can have actually more options based on the request that is being called. But for here, we only mock one response, and the response would be that it has a response code of 200, it has some header of application JSON, let's say, and it has the success body that we created here, the JSON. Okay, so next up, I create what I'm testing is here is the implementation of the API, I pass on the HTTP client, now the mocked one. And actually, this is like one way of doing it. On our project, we just agreed we'll do it, that we would always name the part of the code that we are actually testing by SUT, which is system under test. So this is what you test, and all other things around it are mocked to be able to run this test. So here we are getting into the coroutine stuff a bit. So normally these are suspend functions, so you need to run them in a coroutine scope. That's why you have this block, run blocking, which actually runs like sequentially runs these lines. And yeah, so what do? We fetch the response. We want two values from the API. We get the response. Now we expected a success response. So what do we test? This is from the truth library. So we assert that this response is a success of any type, and this is true. After we know this, then the test can continue, and we can actually parse it to a success response, and we'll work only with that in this scope of let. So the first thing that I'm interested in is that the actual list that I got back was of size 2. Then I'll check the data itself for the 0th item and for the first item. To avoid some boilerplate, I created an extension function on the apod DTO objects, which is data transfer object. And I'm just passing all of the expected values that I'm expecting. And here I'm checking if the expected values are met. So for example, here, I think the most important part is that I parsed my date properly. So I'll test that. I create a calendar instance, and I check that if the year of the date is the expected one, if the month, and if the day of the month is the expected one, and then simply just checking if all of the fields from the JSON were properly parsed onto the fields of the object. Cool. So that was the happy path of API responding with a actual list of values. Now we can test an error. So the error, once again, for the dispatcher, we provide a different mock response, which would be set response code for 3, same header, but it will be the error response of wrong API key. We will test the apod API, pass on the client, and we'll fetch data once again. But now we expect that the response, this is one of the other things that you can use with truth, that it is an instance of error. So yeah, cool. And then we'll assert that response message will be the wrong API key. So now, after we have that written, we can actually run the tests. And we'll see the result. And the result is that the test response success succeeded, but the test response error didn't. And what went wrong was that the expected error message of the, here, if I scroll to the code, here the message was expected to be a wrong API key. However, for some reason, it was client request, invalid, client error, and so on. So this is, this actually is a real life example that happened to me. And it's caused by the fact that the CTOR library for networking that I'm using, I updated it to the latest version, and from the latest version, it actually for all of the 400 or 500 requests, it fails or throws an exception instead of just giving you the result. And to fix that, you need to pass on the parameter when you're setting up of expect success to false, which will not always expect success and not always throw an exception if it's not a successful result. So this is, for example, one of the ways to avoid some misbehavior in production. If you update the library, you think like, okay, everything works fine. I tested my app, cool. But then you're getting a different error that you expected to get just because you updated a third-party library and you didn't realize that this was a new field there that was by default set to true. So if we now run the tests again with the HTTP client set up properly, we'll see that both of the tests pass, and that's the beautiful view that you get when your tests pass. Cool. Any questions?
Nothing so far.
Nothing so far. Okay. I don't know if everything is so clear or everything is so unclear that there's no questions. Cool. So let's just get to the next layer, which would be the persistence layer. So I just go to apod test, and here it will get a bit more complicated, but just a bit. So this is one of the tests where we actually need to run it with Roboto, because to initialize a database, Realm database, we need context, and context is an Android thing that we all love and hate at the same time, I guess. So you just need to provide these annotations. Also, there's more setting up to the test. So here in this case, I'll be having a class context of the variables, so that I can use them in different tests once I set them up. Then I need to employ a task executor rule, which is a rule that will execute all of the tasks instantly and synchronously in the order, so that there's no race condition that might make your tests misbehave and not act deterministically because some action was done before some other in a different order as you expected. Then you have this before function, which is something that is called for this whole testing class before any of the tests are run. So what do we want to do before? Well, we want to set up our like initialize our database and our apod DAO. So the database will initialize in this way that is super not recommended in production, but normally in tests it's fine. So you initialize it as an in-memory database. You set the transaction executor to single thread executor, exactly to also avoid other race conditions. You allow queries on main thread, never do this in production, and then you just call build to create a database. And then the apod DAO is created from the database by just calling the interface. Cool. After this, after all of the tests run, we want to close the database so that we clean up everything that we clean up all the mess that we did for the testing, basically. So this runs after all of the tests run. Cool. So let's just look here on the first test. Oh. So here I'm just wrapping the whole block of the test in run blocking, because we'll be using suspend functions right from the beginning to the end. So what do we do here? First, before I do anything, I just okay. So we test insert and reading of the data. Before I do anything, I just check the database that I get all of the rows that are in the database. And first, this is a flow, so a flow of list. And to get the current value of the flow, you just call first on it, and you get what's there currently. It's a yeah, it should be a suspend function, and yeah. And you expect the data to be empty because you didn't insert anything into the database. Then I create some mock data. I create some dates. As you can see, I apply a specific time in milliseconds to actually avoid having random dates that might break my tests. And I update the data in the database by creating a mock data. It's just a function that creates the mock database with the dates that I provided and with the IDs of 0, because my database auto like creates the primary keys automatically. So if we go back to the function, then after that, I then get the data after I inserted it. I get the data the same way, and now I expect the data to be of size 2 because I inserted 2 objects, and I'm expecting this might be a bit of down way of doing it, but I'm expecting one ID not being the same as the second ID because those should be all unique. And then I'm checking data, and once again I have an extension function that actually checks if all of the expected values match the values that I got from the database. Cool. Then what else can we test? So I'll just here I came up with a scenario. It's actually like a game. You just came up with things that you think, okay, this could happen, so I'll just test that. So I insert data, then I read it, then I insert different data, and then I read it and check if I have the correct data stored in the database. So I update the data with mock data 1. Actually don't care about that much because I already tested that in the first case. Then right away I updated with other mock data, with different ones, which will, I think, contain only one entity. Yeah, that's great. Only one element. Yeah, it's got too much. Anyway, so I assert here that the size is 1 and that all of the values in the object are as I expect. Then here I'm testing that if I insert empty data and read, first I insert some data, then if I insert empty data, then it works, and I assert that the size of the data that I get then is null or 0. Sorry, it's not null, it's 0. Cool. So we can actually run these tests and see what happens. It's taking a bit longer because it's with the Robolog check. So that's why it's always good to try to write it in a way that doesn't need it, but in this case it was not ever avoidable. So you can see the first test actually takes 10 seconds until the whole system just fires up, and then the subsequent ones are already fine, I guess, with just 100 milliseconds. Cool. So that was testing of insertion and reading from the database. Then we can go to the persistence test. So the persistence is just one extra layer so that we are not directly communicating with a DAO, but there's one more layer that actually transforms the entities that we are getting from the repository and passing on to the database, that we transform them into the database entities of room. However, there's once again one thing to show here, a new thing, I would say. So once again, we have the persistence here. We'll initialize it later. But here we have the APOD DAO that we need to inject into the implementation of the persistence. But at the same time, we already tested the APOD DAO, how it works, that the insertions into the database work correctly. So we're not testing this anymore. This is the thing under test. So we just want to mock this. And one way of mocking things, and this is where it's great to have interfaces, is that you are mocking the methods that the interface exposes. So in this case, is this update data method and or like function, and the get all function. And what we are doing here is that we're actually having a local variable that is a state flow, mutable state flow. And if at the beginning it only contains an empty list, so if we start listening to get all, we get a empty list because that's what's there. However, if we call the update data function, then it's just a dummy approach, but it will update the value of this variable, and now the flow will emit the value with actual data that we passed on here. So let's see how it works. Here, before I just initialize my my SUT, could be done here as well if I switch the order of initialization of the variables. But anyways, so what do we have here? I want to check. I want to run a test that saves data to the database and reads it. Here, as you can see, before we had this block initialized by run blocking. In this case, new thing, run blocking test. That is specifically just for tests, and it has some edit checks and edit functionalities. For example, one of the checks that it's doing is that all of the channels and flows and coroutines that are running during the test, they have to be finished by the end of the test. Otherwise, it fails. So if you have some of the open ones, like I don't know, an open channel that didn't finish or it didn't cancel it, then it will fail the test. There's other goodies that the run blocking test is giving you. For example, you want to test a timeout of an API request, and your timeout is 30 seconds, which would take 30 seconds for the test to run, and that's not fast, which was the first rule of testing. So this run blocking test actually gives you an opportunity to call a function called advance time by, where I would pass like 30 seconds. And this would just like act as if already 30 seconds passed, and then we'll check what happens next. So still the test will run in just a couple tens of milliseconds or even milliseconds, but it will kind of simulate of the time passing by 30 seconds. So that's just an example of why run blocking test might be useful. And to get back to this particular case of saving data to database and reading, we'll create some mock dates, create some mock data once again, and then we are checking that before we update the data, that there's an empty list, that nothing is emitted. And after we call the update data function with a new mock data, then we just check. This is a lazy way of checking it, but thanks to data classes who have the equals function implemented, I can just directly compare the two lists, and it will just tell me that if I get the correct data back. Yeah, sometimes you are returning a different different entity type or something, so you would need to do it manually, but here I can just do it really simply like this. Next up, we'll test that we save the data to database and overwrite it with new data. So we first update the database with one data, then we update it with a second set of data, and then we just check, hey, if I listen to the latest value, then I just expect it to be of the type of the second mock data set that I passed on there. And yeah, here I just have the convenience functions for creating the mock data for me. So once again, we can run it. And yeah, passes. Good. Good, good. So, any questions that we have?
Not yet.
Okay, cool. So now the things will get a bit complicated, maybe, or like there will be more and more code, I would say. So still an opportunity to ask a question. Some updates available, that's cool. Good, so we move on to the repository. So this is where the two data sources from the API and from the database are being collected and then emitted as one data source, basically. Here we'll have quite a lot of initialization, as you can see, before we start testing. So I'll try to explain as clearly as possible what's happening here. We'll start using the mock functionality. That's basically almost the same like implementing an interface, but for some test cases, you can have interfaces, let's say with 10 functions that you need to implement. But for your test case, you only are interested in one. So you don't want to implement all of them and have unnecessary unused code in the test. So you just use the mock of which interface you want to use, and you specify which function will do. So for example, in this case, every call to this function, and I don't care about what parameter I pass on here. So there's a convenience for this, that any that returns whatever. Here the parameter would be the count of the pictures that I want to fetch, but I don't care about that at this moment. So for this function, the answer will be this. The reason why it's a co-every is because this is a suspend function, so I need to call it in a coroutine, so that's like a co-every. And the reason why it co-answers because it also needs a coroutine scope for this part of the code to run. And the reason is because I have this receive function here, and I'm receiving a value from this channel. So this is basically mocking that when I call fetch, I don't get the answer right away from the API because that wouldn't be a real life scenario. But I will control when I get the answer, and the answer I will get when I emit a value to this channel. So when this channel gets the first value, it will receive, and then the whole this function will respond with this success. We'll see how it works in the tests. Then next up, I have the same functionality I just create an API instance that actually returns an error. So there's an error channel that I can control when it emits. I create some mock data with the dates that I provide here. I think we already went through a similar thing, so I won't spend too much time here. Then I have some saved data that is a state flow, which is yet another thing how to control what your function is returning at what point. So for example, here the apod list would be returning the mutable state flow based on with what data I updated here in the update function. Then I have some initial data that is not empty because this one is initially empty. So I want to test also what happens if it's not empty at the beginning, and then the persistence instance is created accordingly. And finally, we get to what we actually want to test. So everything above is mocked because we already tested it in its own modules, but this is the module where we test the repository. So we pass on the API instance and the persistence instance into the repository implementation, and we have the different kinds. We have when it's empty at the beginning, when it's not empty at the beginning, and when the API throws an error. And we'll be testing what happens in which case. So here, super simple test, but it will once again show something new, and that is that I will launch a job that will fetch the data from the API. If I just did it without this and just basically did this, because this function won't return until I emit something in this channel, it will be just stuck here on this line and it will never finish. So I need to launch it as a new job, and then while it's running, I want to check that the current state of data is that it's loading and it's returning me an empty list. And then as I launch the job that hasn't finished yet, I need to cancel it at the end of the run blocking test, because otherwise it would fail. It's because it's not a finished job. So yeah, I can just quickly show that if I run it, then it should fail. Hopefully it will fail. Yeah, okay. So it throws an error that it's an uncompleted coroutine error that test finished with active jobs. So this is the job that actually wasn't finished, and if we uncomment it and it again, then it should be all fine. Yeah, all good. Perfect. So then once we know how this works, then we can move on to a more sophisticated test, and that is test loading with cache data. So what do? I start fetching the data from the API. I check that the fetch state is loading, and I get the list of the items that the loading returned to me. And actually, my mock data say that I have already some data cached. So I'm expecting the data to be of size 2, or the list of data will be of size 2. And then I'm checking the data contents as usual. And then at the end, after all I do, I need to cancel the job once again. So next up, I'll test that after the loading, I'll get a success response. So what do? I run a job with the data being initially empty. Then I check that I'm in the loading state. And then this is where it happens, that I send the value to the channel. So this simulates that the API returned the value. So this function will finally return, and the fact that it returned now ensures that my fetch state will be a success, and that my data will be updated with the data that I passed on here. So it will be, the size will be equal to 2, and I can check the contents of the data. Of course, cancel the job at the end. And then I think this should be the last one here. Yeah. So this will be testing an error. So I'm fetching the data. I'm checking what the state is. It's loading. And then into the error channel, I send the value test error. And then I'm checking if the fetch state after sending this value is an error. Okay, it's true. Then I just, I just know that it will be an error. So I lost the word. Yeah, you understand. And you assert that the error from the data is the test error that I passed on there, and that the data that I had mocked there as already cached data that will be equal to the expected values here. Cool. And of course, cancel the job at the end. And so we covered API, we covered the database, the persistence implementation, the repository, and now we're getting to the view model, which will be the last step with some new stuff once again, but not too much, I would say.
There is a question actually.
Oh, there's a question. Perfect. Perfect.
Yeah. So I want to ask about API module tests. Can you please explain about mock web server, HTTP client, anonymous dispatcher object? Are these for general testing or specific to Ktor?
Okay, if we go to the API test. Well, the HTTP client you create is creating using Ktor, but like other networking libraries would provide you with creating your own HTTP client. I think just the signature will be the different. You will initialize your serialize it differently, but it's a general approach of how you create the HTTP client. Then the mock web server that's usable for every case. So it's not directly bound to being used, for example, with Ktor or with COROUTINES or whatever. It's a separate. It's just OK HTTP3 mock web server dependency that you add to your Gradle as a test implementation. I know if that answered the whole question.
There was also a question about the anonymous dispatcher object.
Yeah, this one. Yeah, I assume it will be this one. Yeah, this is just yeah. It will as the mock web server is working, it's not tightly bound to whatever technology we are using here. It's just basically implementing the dispatcher object that has one function that you need to implement dispatch, and that here you control what the objects what the responses will be. Like here you can have more options, that if you want to return different things, for different paths, then you can have a when, and then you just then you return a different mock response for different path, maybe some error response for some paths, as you wish. Yeah. I don't know if now I answered all parts of the question and if it's sufficient.
I believe you at least answered all the parts.
Okay, cool. So if it's not sufficient, then please ask again, and I'll try to go into more depth if I know the answer. So are there any more, or can continue?
That's it for now.
Okay, cool. So here we are testing the viewModel. We are once again using the instant task executor rule to ensure that all of the background tasks are run instantly and in parallel, and also test main dispatcher, which is necessary for when you launch a coroutine, for example, from viewModel by calling viewModel scope launch. Then you need to have this dispatcher, because otherwise the test doesn't have any dispatcher assigned to it, so it needs some, and the best option would be to have the testing one. I actually commented out using the dispatcher. The tests will pass with it, but it just won't be as nicely green as normally it is. So as you can see, you get, for each test, you get an exception that module with main dispatcher had failed to initialize, and for tests, dispatcher set main from coroutines module can be used. And it's pointing me to this function where I'm launching a coroutine. And yeah, so the tests will pass, but it's an easy fix, let's say, to set the dispatcher set main to the testing dispatcher, and all will run smoothly without any exceptions being thrown during the test run. Okay, so in the setup, you set the main test dispatcher. However, after the test, this is quite a big thing to do, to set a main dispatcher. Then after, you need to clean up all of the test coroutines that you ran with this dispatcher, and then reset it to actual main, not the testing one. Cool. So here we are testing the viewModel, and we will mock the repository, because that's the only thing that we are injecting into the viewModel. So we don't care about API, we don't care about persistence, about DAO anymore. We just, this is the only source of data for the viewModel. So this is the only thing we will test. We'll have two kinds of mock data, and a flow that will be here. We will be mocking the repository in a way that if we fetch something, then we actually are too lazy to test that, so we don't like test this flow anymore. We just for every data state, we return the data state flow so that we can control what it actually returns. And yeah, after I already went through, and then here we just have two simple tests. So here we'll test success in the run blocking test block. At the beginning, when we ask for the view state, we want it to be loading, and the data will be empty at the beginning. And then when we provided some data to the repository by filling the data with success and mock data 1, then we will assert that that the view state is equal to what we expect. As you can see, this is really similar naming, but this is a fetch state that we are passing there, and we are expecting a view state. So we're basically testing some transformation there from one sealed class to another. Then we can test the loading from cache while fetching. So first we'll pass on some mock data into the state flow. So already the first time we start collecting this data, we will have some data in the state loading, and then after we pass on the success into the repository, then we'll know that the view state will be a success. And here we have an error. So yeah, at the beginning we are in the loading state, then we mock an error. We'll see that that the data that we get is of type error, and that we have two list items there. This is the first one, this is the second one. All the asserts pass, and then we also check that the error actually reads the same value like we passed on here. And the very last test is to fetch empty. So we just emit a value of empty, and then we check that the view state of the view model is emitting a state of empty. Yeah, and that's it. So we tested our API layer, our database, our persistence, and then combining the data in the repository, and then the view model consuming the data from the repository. So I don't know if we have now any questions. I'd like to wait and give people some time.
There is a question.
Mm-hmm.
How do you come up with test names? For small tests, it's easy, but when it gets complicated and you want to specify the conditions, it can easily get too long.
The test names of the a good practice is not to make the tests the same. Each test function should only test one thing. Yeah, there can be different conditions. Sometimes it really gets long, but I'm more fan of being descriptive than like shortening it too much. I don't think it's such a big deal. I don't actually have a recipe for that. I would just write exactly what the test actually tests. I know it's probably not the expecting answer, but like not much helpful. But because then if you write the test and then a year later it starts failing, then you will just appreciate that you maybe even written, I don't know, 2 sentences to describe it. Do we have anything else? So where we finished in the presentation. Thank you. Oh yeah, thank you. So I don't know if you want to wait a bit more for some potential questions. Otherwise, I thank you all for coming, listening. Hopefully, it showed you that testing does make sense, that it's not so difficult once you know how to approach it, and what to test and how to test, how to mock, and that actually the feeling of tests running green is rewarding enough of the effort put into it.
There is a question.
Mm-hmm.
Can we use run blocking test rather than run blocking in your test examples?
I don't understand if we can use run blocking test instead of run blocking.
Yeah.
In some of the examples.
Yes.
Yeah, I do realize that, for example, in APOD DAO test, I think it was, that here we only had run blocking. The reason for this is that the room database is built in Java, and there are some there's a different way of running background tasks. So this run blocking can only perform properly with coroutines, and if there's another mechanism, then the test will actually fail because there's a background task running, because it can't be actually cancelled. We don't have enough power over it. So in some of the cases, we need to do it just with run blocking because of the limitations of the third-party library that we are using, in this case, a room database. If I understood the question correctly. Hopefully I didn't answer something that I wasn't asked.
There is one more.
Nice.
Why is there so many iOS talks and Android got one today? We can talk about it in person, I guess.
Yeah, that's the reason is that we to have more iOS developers, so that's why we are hiring, and that's why we need you to join us so that we can have more Android talks.
Thanks. I wouldn't say better. So if you want to see more talks without our faces, you will need to come work for us with us and join us.
Yeah, that's apparently the way to go. Any more exciting questions? I know I don't have any more jokes or memes or anything, so I'll just leave the word to Katka.
Okay, thanks, Juraj, and thank you everyone for spending this evening with us. I think it was really nice, and I really enjoyed it. So hopefully you as well. So the next. And I can see that in the chat that there's this message. I hope these sessions continue. So I can already promise you that we are planning another Android talk, which is happening on May the 6th. So you can look forward to Flutter app development process for both Android and iOS. So hopefully that would be as successful as today's event, and you will enjoy it and join us as well. So please stay tuned. We will publish it as soon as possible, and you can find it on our websites or on our Eventbrite page or Meetup group. So if you don't want to miss that, just check these sites out. Okay, and since we want to be proud of everything we do at STRE, we would really appreciate your feedback through the survey, which will be open right after you close your Zoom window, or I will be posting it right now to the chat, so you can go straight there, so you can find it there as well. Okay, it's there. Sorry.
I have one more thing to add, maybe. There was a question about the testing of the legacy code. I can recommend the book written by Michael Feathers called Working Effectively with Legacy Code. It's a kind of a handbook for these cases. It basically lists a lot of scenarios that you might encounter during the development and the way to approach testing in those legacy code bases. It's really interesting. I highly recommend to have it like hard copy and to take a look at it every single time you have some doubts about testing.
Okay, so we will definitely put this tip also into the after event email, so you can check it out over there as well. And I have one more question from YouTube channel. What about Compose for Android? I guess it's a tip for another topic. So just please feel free and let us know what you would like us to cover next time. But guys, do you have anything towards this topic right now?
We're definitely exploring Compose these days. We're also participating on the weekly challenges from Google. I don't know if you know about it, but there are challenges from Google where you can actually win prizes by coding some Compose applications. The outputs are really cool. So if you can maybe even check the Twitter with the hashtag weekly challenge, I guess. You can see the example apps that people created in Compose. They're really awesome. And yeah, we will definitely prepare a talk about Compose in the future because we would like to test it a little bit in production as well, as soon as it's kind of more robust, a little bit more tested. But yeah, as Katka said, basically, if you have any ideas about the topics you would like to hear here, feel free to contact us and we'll be happy to provide it for you.
Okay, so I think that's it for now. So thanks again to our speaker, Mr. Moderator, and you guys that you all attended our event. And thank you and have a nice evening. Bye-bye.
Thank you, everyone. Thank you, Katka, as well. Bye.
Bye. Thank you, bro.